Okay, welcome to our session. Thank you so much for attending this session. We have a lot of material to cover, so we're going to do a quick introduction and go through the material. My name is Vahid. I'm part of Storage and Availability Product Management team focused on Virtual SAN.
Hello everybody, my name is Rakesh. I'm on the Storage and Availability team as well, and I'm focused on Virtual SAN as well.
My name is Neil Creswell, CEO of Indonesian Cloud.
Before we get started, Neil, do you want to give us a quick summary of your environment? So as we go through the slide, Neil is going to share some of his experience with the product, and I think it's going to be good for the audience to know what kind of environment he's running today.
Okay, so we've been running vSAN now for a little over 12 months, and it's now expanded out to almost a petabyte of storage and about 1,500 virtual servers, which are now running upon it. They're all mission critical workloads. So nothing test dev, all absolute mission critical.
Thank you. So here is a disclaimer. If we say anything about the future, we're not going to discuss roadmap here, but if we say anything during our conversation or Q&A, please don't use it against us, don't sue us, so that we can talk about these things in future. The other thing is that let's ask the questions please at the end, so because it's going to be easier. I think they're recording the session, so they said that we're going to spend the last 10 minutes on the questions. So please keep your question at the end and also fill out the survey so we get feedback to enhance our sessions. Here is a quick agenda about what we're going to be doing today. We're going to do a quick introduction. We're going to talk about customer challenges. Also, I'm going to spend a little time on software-defined data center and HCI. I will go through this very quick because I'm sure most of you guys are already aware of this and you'll know it. Then Rakesh is going to provide a quick overview of Virtual SAN. And next, we're going to talk about what's new in 6.1, and then at the end, we're going to talk about new features, and Neil is going to share a lot more details about his configuration as well. Quick question for audience. How many of you are familiar with vSAN today?
Should be all.
Almost everybody. Is there anybody here that doesn't know much about vSAN? That's great. Okay.
How many people are running it?
Customer challenges. We talk to customers in daily basis, and most of the time, the big challenges our customers sharing with us is cost. It's very expensive in terms of hardware. It's gonna, for example, here we did the math for 120 terabytes. It's going to cost you $1.2 million. Performance and inflexibility, right? A lot of the traditional way of doing storage was very LAN-based, and that's causing a lot of challenges for our customers in terms of management, automation. And it's operationally, that's very complex as well. When we talk to a lot of customers, they tell us that creating a VM might take 5 minutes, but having the VM running, it takes maybe 90 days because of the fact that you have to configure the networking, you have to configure, go talk to storage admins. So it's a very long time process. And our key objective was with SDDC and hyperconverged infrastructure is to address those challenges. And to do that, what we did was in traditional ways in open systems, and the way typically we were doing storage before, was you take networking and compute and storage from different vendors, you put it all together, which takes a long time, right? And we are moving that, and we are coming up with new kind of way of doing infrastructure, which is hyperconverged. And in this model, you have your storage, networking, and compute in all one infrastructure. And it's going to be all based on x86 or commodity servers. We're just going to have a lot of benefits in terms of simplicity, cost, scalability, and performance. And Neil is going to share his experience later. He's running around 1,500 VMs and almost petabytes of storage on vSAN. So that's another kind of indication of how customers are using the product. The other thing I want to mention here is, as we are looking into management of this infrastructure, we want management to be all done through vSphere, so that through vSphere you can manage the whole infrastructure, so that the management and automation and overall the time to value is going to be much faster compared to traditional ways. So there are multiple ways to actually do hyperconverged infrastructure today. There is ready nodes that Rakesh is driving that, and it's available today. We are actually focusing a lot more on ready nodes now. You can go, these are based on, for example, HP, Dell, and major OEMs we have. You can go and build your virtual SAN based on these ready nodes, and it's a very fast we have different sizing so that you can go and actually do the sizing and then get the configuration you need for your infrastructure. And the other way of doing it is EvoRail. EvoRail is, the way to look at it is that If you want to get the full hardware and software solution delivered to you so that you can go provision your VMs very fast, that's the story behind EvoRail. And as you can see, Evo SDDC is becoming more, we are talking more and more about Evo SDDC, which I think GA is going to be end of this year or next year, if I'm not mistaken. And that's also, the next step is going to be about also integration with NSX and network virtualization. And it's going to be a rack solution. Once you get it, you can actually configure it. I think our goal is to do less than 2 hours so you can be up and running. Key use case for customers, we have already more than 2,000 customers using Virtual SAN. I think it's a lot more than that now, by now. The key use case we are seeing customers using Virtual SAN is for virtual desktops. Initially, we have a lot of customers using it for VDI. We had a lot of customers initially using it for IT operations. These are the configuration like management clusters and for DMZ and that kind of use case. Remote office, branch office was another use case. A lot of the customers were using it. As a matter of fact, I think one of the biggest deals we had was for remote office, branch offices. And in the past, we used to have 3-node configuration for Robo. And as part of 6.1 release, we added support for 2-node for remote office, branch offices as well. The last thing I want to mention, and I think Neil is going to talk about it later, we have a lot of customers actually using vSAN for business critical applications. And we already published reference architecture for SQL AG, Exchange DAG, and Oracle RAC is coming. I talk about Oracle RAC at the end as well. And also we are certifying SAP HANA as well. So we are going to focus a lot more on business critical applications because that's what customers are asking us and that's the direction we're going. I talked about 2,000 plus customers. Neil is one of our best customers we have and he's going to talk about his configuration. But you can see other customers. We have customers across different verticals, from education, finance, to high enterprises using vSAN today. Rakesh?
Yeah. Next slide. So a quick overview on vSAN. Most of you might be aware, vSAN is software-defined storage, and it is optimized for VMs. It runs on any certified x86 server platform. Essentially what it does is it pools magnetic drives and flash devices attached to physical hosts that are members of a vSphere cluster and creates a virtual data store out of it. We deliver enterprise level scalability and performance, and with vSAN essentially we look at it as a paradigm shift to viewing storage. So with vSAN, we allow applications or VMs to define their storage requirements. So it's basically a top-down approach where an application controls its storage requirements in terms of performance, capacity, and availability. So when you create a VM, you can tell it how much performance, capacity, and availability it needs. And then vSAN sits in the ESX kernel and acts as a broker between the application and the underlying infrastructure. The advantage of this is, if you look at traditional storage, it used to be a bottom-up approach. You would provision a LUN, you would end up over-provisioning, end up spending a lot of resources and time. And we address all those concerns by letting the application dictate exactly what it needs in terms of performance, capacity, and availability. And this is done through per VM storage policies. And as you know, vSAN is also very deeply integrated with the VMware stack, the vSphere stack. So with vSAN 6.0 earlier in March of 2015, we introduced the Allflash architecture. So right now, vSAN has two different architectures. There is a hybrid and an all-flash, right? Both are two-tier architecture. The difference is that in the hybrid architecture, the SSD or flash device is used as a read and a write cache for performance acceleration. And the magnetic drives are used for persistent storage. However, in the all-flash, the tier 1 and the tier 2, the caching and the capacity tier, are SSDs or flash devices. The difference being that the caching tier is 100% write cache. And as a result, it requires, you require higher endurance, higher performance caching devices. So like PCIe SSDs or NVMe, or any SSD that has over 100,000 writes per second and has a relatively larger endurance so that it doesn't wear out quickly. As for the persistent tier, we support capacity tier SSDs, more of read-intensive MLC kind of SSDs with lower endurance because writes are only periodically destage from the tier 1 to the tier 2. So you don't need as much endurance on the capacity. And all the reads directly go to the capacity tier. One big difference is that between the hybrid and the all-flash configuration, we see about 40,000 IOPS per host on the hybrid platform. This was benchmarked with 4K block size, 70-30 read-write mix, random I/O, and for the same workload on all-flash, we get almost 2.5x performance. So we get 90,000 IOPS per host. The key difference being that with the all-flash architecture, you get consistently sub-millisecond latency response times. So for transactional workloads, for OLTP or VDI, wherein for workloads which require consistently high performance and low latency, sub-millisecond latency response times, the all-flash architecture is very ideal. And if you do a TCO comparison between an all-flash running on vSAN versus any other comparable vendor, vSAN comes out almost 30% more efficient from a cost perspective, 30 to 40%. I think we covered this, so we can move forward.
So let me cover what's new in 6.1 really quick. So we had three categories of focus for this release. The first one was enterprise availability and data protection. We introduced stretch clusters. I think a lot of you here are familiar with metro clusters. So we introduced vSAN stretch clusters mostly for our customers in Europe, because a lot of the customers we have here, they tell us that stretch cluster and active data centers are very critical to their data center architecture, and that's one of the main reasons we introduced this feature. Also with vSphere application, before we used to do 15-minute RPO. A lot of the customers asked us to do 5 minutes, enhance it to do 5 minutes, and now we support 5-minute RPO with vSphere application. We have support for SMPFT. We had many customers wanted to have interop with SMPFT on vSAN, and we're supporting it. And we added support for Oracle Rack and MSCS technologies as well. In terms of management and troubleshooting, we did health check plugin for hardware monitoring and compliance. We introduced vRealize operation integration, and Rakesh is going to talk about a lot more details on this. And we added support for cloud-native applications. In terms of new hardware options, we added support for 2-node clusters for remote office branch offices, and I explained a lot more time on that. We have new ready node platforms, and Rakesh is going to go through a lot more details. And we added support for new hardware options, and the key things here are NVMe and UltraDIMM support, mostly for the applications that require a very high, a lot of performance and very low latency. Let me provide a quick overview of stretch clusters. In the typical stretch clusters, you're going to have 2 main sites. So we call the main sites, in terms of vSAN modeling, we model that using fault domains. So imagine, for example, a customer who could have 2 sites, one in New Jersey, one in New York, or we have, for example, I talk to customers who have 2 main sites in Munich. And the way it's going to work is, in terms of networking requirements between the 2 main sites, you need to have less than 5 millisecond latency, and I explain why we need that. Also, ideally, you need to have 10 gigabit per second network bandwidth, and we require configuring multicast between the 2 main sites. If you're familiar with vSAN architecture, we need 3 fault domains to function. And to do that, we actually introduced a new concept called witness, which actually gets located on the 3rd site. The way you deploy it is, it's an OVF. We actually give you an OVF. You deploy the OVF. And once you finish deploying that OVF, it's going to deploy an embedded ESXi that you can use to create the witness on top of that. If you look at network configuration between the main sites and the witness, we are a lot more flexible there. We require 100 megabits per second. You can go all the way to 200 millisecond RTT in terms of latency. And the communication between the main sites and the witness is going to be L3, which is IP-based communication. One thing I want to mention here is your witness is not contributing to the compute or storage, which basically means no VM is running on the witness. The witness only holds metadata, and it basically includes 16 megabytes of information for each object you have in your cluster. So if you have 1,000 objects in the cluster running on that cluster, you need 1,000 objects multiplied by 16 megabytes for the disk on that witness VM. The other thing I want to mention is when you create this cluster, it's going to be one data store, and when you create your VMs, it's completely transparent that this is a stretched cluster or non-stretched cluster. So you just create your VMs the way you used to. You specify your failure to tolerate. You specify your capacity and availability and the performance requirement, and we take care of the rest. Today, with this 6.1 release, we're going to scale to 31 nodes, which basically means you're going to have, you can scale all the way up to 15 node on site 1, 15 node on site 2, and then 1 witness node. I get asked a lot of times about the witness licensing. There is absolutely no licensing requirement for the witness VM. The witness VM, we've done all the licensing so that when you deploy the witness, the OVF, it gets deployed and there is no requirement for a licensing at all. Spend a lot of time on 2-node remote office branch offices as well. As I mentioned, we have a lot of customers already using 3-node vSAN for remote office branch offices. However, a lot of the customers were asking us for 2-node solution because, first of all, they didn't want to pay for the 3rd node. And second, we have a lot of retail customers who don't have a space for the 3rd node in the remote sites. So the configuration we came up with was you can deploy the 2-node in the remote site. You're going to deploy a small witness VM in your central data center. Or that witness VM also could be deployed on a 3rd node in the remote site as well. So for example, we have a customer who actually they have 2 nodes in the remote site, and they have another node that they're using for backup, and you can deploy that witness VM on the 3rd node as well. But in this configuration that I have here, at large scale, typically customers manage the remote site with a central vCenter. So in this case, you could manage 200 to 300 remote sites with 1 vCenter in the central data center. And in there, you can deploy your witness VM. And the combination of that witness VM with those 2-node cluster becomes a vSAN cluster. And that's how we are delivering 2-node. One other thing I want to mention is the network requirement between the remote site and the witness in the central data center. We basically went with T1. And T1 is something that most of the customers, when we talk to, they have T1 lines between the remote site and the central data center. It's basically 1.5 megabits per second. And we support all the way to 500 millisecond RTT. One last thing is that at steady state, when there is no failures going on, there is absolutely no network traffic going to the witness, except a small heartbeat, which is once a second. So overall, if you monitor the network traffic between your 2-node in the remote site and the witness, you barely are going to see any network traffic during the steady state. The only time you're going to see a lot of traffic is when you're creating VMs or one of the nodes fails. In that case, we actually send a lot of information to the witness.
How many of you in the audience are planning to deploy a 2-node vSAN robo? Okay. And how many of you are interested in stretch clusters?
Perfect.
Right. There you go.
That's great. I spent a lot of time on business critical applications on vSAN. We are supporting Exchange DAC and SQL AG on vSAN today. We already have reference architecture, so please reference those if you want to utilize those applications in your environments. And also we have Oracle RAC support on vSAN as well. Rakesh?
All right. So before I get into the specifics of the new vSAN monitoring and management aspects that we've introduced in the latest release, I'd like to kind of give you an overview of our strategy for management and monitoring. So I tend to run into 3 types of customers who ask for management and monitoring. One, those of a set of customers who want management and monitoring in vSphere, so they want it on the web client. 2, we see customers who have standardized on vRealize operations, and just like they manage large vSphere clusters today, they want to extend that to manage vSAN. And 3, there's a third set of customers who have standardized on their own tools in their environment, like for instance Zabbix. And what they want is us to expose APIs that they can integrate with, so that they can just standardize and continue with their standardized architecture. So our management strategy is 3-pronged. We have to support, there's a good mix of all 3 customers. So we have to support all 3 customers. And the way we are doing that is for the vRealize operations, we just recently introduced a new storage pack, a management pack for storage devices, very specific to vRealize operations. So what the management pack does is it gets data it collects metrics from 2 sources. One is it collects metrics on the physical devices. So we have, we integrate with a SIM provider that sits in the ESX kernel, which collects all the hardware metrics like SSD life, number of errors, the hardware lifetime, the magnetic disk, sector count, and so on and so forth. So we get all those metrics, those hardware level metrics from the ESX SIM provider. The second source is from the vSphere vSAN cluster itself. We expose a bunch of metrics through the storage APIs. Now what the management pack does is it collects metrics from the virtual metrics from the cluster, it takes the hardware metrics from the ESX SIM provider and combines this and builds a decision engine. And with the vRealize operations management pack, now we provide things like global cluster visibility. So we have dashboards that are very similar to what we have with the vRealize operations, but these are more customized for vSAN. So kind of same look and feel, but very specific vSAN metrics as it pertains to health, risk, and efficiency. And we also provide proactive alerts and notifications on impending failures. So using the combination of metrics from the ESX SIM provider as well as the storage APIs, we are able to predict disk failure issues. We can give you SSD wear out indication, wear leveling, and so on and so forth. We can come back and tell you this SSD is likely to die in this time frame, right? It's 80%, it's hit its 80% threshold. So if you don't want to lose a disk group, go ahead and replace the SSD. So things like that. And also we give you proactive alerts and notifications on things like network issues, performance issues, if you're running out of capacity, if you're running out of compute, you're running out of capacity, we tell you you might want to add a host if you're running out of compute, or we come back and tell you you want to add more storage because you're running out of capacity. Everything is done in a proactive fashion so that the customer is informed well in advance. We also support what we call capacity planning. So basically, what the management pack does is it trends vSAN workloads over a period of time. And so for instance, it looks at what the demand and stress of a vSAN workload is over the last 6 months. And with that, it helps you predict how much more hardware you need in the next 3 years, for instance. So you can do this all, it's an interactive capacity planner, so you can go in and it'll tell you exactly how much more hardware you need to procure. So with that, I'd like to ask Neil to share some of share some insights on how he has been using the vRealize operations management pack in his environment. He has a pretty huge environment, and he needs to, as you can imagine, you need to proactively monitor this environment. So
okay. So I've been working with storage for a long time, right? Since I was 18, and I'm not young anymore now. And I always liked to be able to see storage, see what it's doing, log into management tools, and able to say, okay, I can see how busy the arrays are, the LUNs are, the disks are. And before I decided to take the leap of faith into Virtual SAN, it was, well, how do I get that same level of visibility and data so we can actually track it back to what is the platform actually doing? How busy is it? How much data is used? Do I have enough cache, not enough cache, enough spindles, not enough spindles? And that's where the actual vRealize came in. It was able to give us the very detailed insight into how busy is each single hard drive that makes up the cluster. How busy are the SSDs? What is the overall latency? What is the latency per drive? So without that kind of tool, you'd be blind. So to say to somebody, trust us, jump from legacy to virtual storage without the tools to monitor and manage the platform, it's just not going to happen.
Right, absolutely. And the other big advantage of the vRealize operations management pack is that Neil has, I think, 4 or 5 different clusters of vSAN running, and he can monitor all of them through a single pane of glass, right? So I guess that's very powerful as well. So moving on to the second tool, which is the health check plugin, which is a plugin into the vSphere web client. This, again, all customers find this very useful, but this also serves a lot of purpose where customers have not standardized on VROps, or you don't have a really large environment, or you're okay getting metrics on a per cluster basis, because the health check is, as of today, gives you metrics on a per cluster basis. You don't get the global visibility of all clusters in your environment. So we've introduced a lot of exciting new features. So it does configuration checks, it does runtime health, it comes back and gives you alerts just like the vRealize operations tool, but at a lower level. It does not really have a prediction engine, so it can't really predict failures like the vRealize operations management pack can, but it gives you a bunch of things like this. It gives you limits checks and so on and so forth. One really interesting and important feature that we've introduced is an HCL check. So now, with the health check plugin, even before you deploy vSAN, you can actually run a pre-vSAN checker just to see, is your hardware compatible with vSAN? Right? Are the controllers correct? Are the servers on the HCL? It actually runs a query in your of your hardware and then compares it with the actual live vSAN HCL. It'll come back and tell you, are the firmware and driver versions for the controllers, are they right? And if they're not, it'll tell you that you need to do these updates. One of the things that we are working on is, and we plan to introduce in the near future, is not just report HCL incompatibility, but also help you fix it. So what the health check is going to be expanded to do is, not only will it tell you that it's not compatible, but it'll also do an orchestrated update across all the nodes in the cluster in a seamless fashion, wherein it'll update it to the latest certified version on the HCL. So I believe that's going to be a really powerful feature. Now then, there's a couple of other tools. There's the vSAN Observer. So if you're a storage admin and you have a lot of experience troubleshooting, deep dive, it's more of a tool that our GSS or support finds very useful, wherein you can look at low-level performance, disk-level latencies. You can kind of drill down into the objects and figure out which object is placed in which part of the cluster and which specific component is actually impacted and so on and so forth. So kind of a low-level troubleshooting tool. Over time, I expect the vSAN Observer to be folded into the health check so that we can give you kind of a single tool for all of that. Finally, we have the vSAN assessment and the sizing and TCO calculator. I'm going to get into details later, but essentially it's a tool that you can use to run in your vSphere environment. So think about you're using vSphere, you're using some other storage, and you want to understand how your VMs are performing and which VMs are a good candidate for vSAN, hybrid versus all-flash. So you install this tool in a plain vanilla vSphere environment with any storage, and it'll come back, it'll run for 7 days, it collects IO traces, and it comes back and it says, with vSAN, if you were to use vSAN, the VMs, these are the VMs that are fit for hybrid versus these are the VMs that are fit for all flash. And then it'll also come back and give you sizing guidelines on which ready nodes to use and a TCO comparison with other storage products in the market. So right off the bat, even before you deploy vSAN, you can use this tool to kind of figure out how much you're going to be likely spending over the next 3 to 5 years.
Rakesh, do you want to talk about adoption of the tool as well? Yes,
so we've seen great adoption of the tool. I mean, in fact, as of today, we have more vSAN assessment customers than vSAN customers. And that's expected because, people are running it in their environment trying to figure out, okay, if I move from this storage array to vSAN, what are the benefits and how much am I going to save, right? So it's been a great adoption, and I encourage all of you to try this tool out. It's a free tool. So essentially there is a collector, so you deploy an OVF appliance in your vSphere environment, it runs for 7 days, collects data, comes back, gives you detailed metrics like how much IOPS is each VM using and so on and so forth, and then all the sizing and guidelines that I talked about. It sends all the data to a portal where we run assessments and give you a detailed assessment report. So your sizing is based on real empirical scientific data as opposed to making a guess on how do you size vSAN. So you don't have to make a guess anymore. It'll tell you based on your actual workloads. I'm not going to get into too much detail here because I covered most of this, but essentially the VROps and management pack is used by vSphere admins, the operations admins, and storage admins. Gives you a global view, dashboards, visualization, has performance capacity planning, and it also gives you smart data. So the data that we collect from the SIM provider is essentially based on smarts, and using the smart technology, we are able to get hardware information, hardware level information, and predict any failures in your hardware failures in your environment. The health UI is more of a per cluster tool used by the vSphere admin, and the observer is more, as I mentioned, is a more in-depth storage admin tool. So with that, I'd like to go into the hardware aspect for vSAN. So just to give you a quick overview, you have two methods to procure vSAN, as Wahid mentioned earlier. If you're looking for a fixed appliance kind of an experience, you can buy EvoRail. Or if you want more flexibility, we offer what we call ready nodes. So ready nodes are pre-validated, pre-certified x86 configurations from all the leading OEMs, and they give you they offer predictable performance and scalability, because we certify these in our labs and we tell you exactly how much IOPS and how much capacity you're going to get on a per platform basis. And the ready nodes, they scale linearly as well. So we had earlier we had ready node profiles for hybrid, low, medium, and high. Now these to European customers, now these might sound like an Audi or a BMW. It's a 2 Series, 4 Series, 6 Series, 8 Series, but it's more intuitive, because as you go from 2 to 8, you increase in terms of raw capacity in terabytes, the number of VMs you can run, and the amount of IOPS you can get from each of these platforms. And similarly for the Allflash, we have the AF6 series and the 8 series.
Can I just add on that? With the vSAN ready nodes, if you are buying servers from a server vendor, if there are issues with that server, then you go through the normal vendor's script. Is it powered on? Is the firmware updated? If you are buying a vSAN ready node, they already know that this is a storage node, and so you basically are able to bypass a lot of the crazy time-wasting script from the help desk.
Yeah.
So from me, I wouldn't even consider vSAN without vSAN ready.
Yes. So the other way to do it, I didn't mention it, is build your own. You can still build your own vSAN using ready nodes as a guidance. But the thing is that when you build your own, the components are not certified to work together. The components are individually certified, but they're not really certified to work in a combination. So this is not to say that it won't work, but you just won't know what performance and scalability to get out of a random combination of components that you put together, right? So that's the other reason why we strongly encourage, VMware strongly encourage that you go with either go with ready nodes or use those as a basis to build your hardware. So you can either procure a ready node as a single SKU, or you can use that ready node as a basis to build your own hardware platform. But as Neil mentioned, if you procure it as a single SKU, you get much better support from the OEMs. So this chart, I don't want to go into details, but essentially, as you can see from the 2 series to the 8 series, we scale in terms of raw capacity, the number of IOPS, and the consolidation ratios on each of these platforms. So we have ready nodes available from all the major OEMs, and you can pick your ready node of choice based on your workload profile, based on which category your workload profile fits in. So if it fits into the 4 series or 6 series, then you pick a ready node in that category. Some other hardware updates. So NVMe. So we just recently certified the Intel P3700 NVMe, and we are certifying a bunch of others that are carried by the major OEMs. So essentially, NVMe is a natural fit for either an all-flash caching tier or a hybrid caching tier, where the workload requires very high IOPS. So it's a very, very good fit for that, and from a vSAN point of view, you will see that we'll have more and more NVMe devices certified for these workloads. So the workloads that run on NVMe are kind of OLTP or VDI workloads which require very high write performance. So those are the workloads for which NVMe is a very good fit. We have certified UltraDIMMs as well. Now UltraM is again a high performance play, but it's more of a low latency play. So you get extremely low latencies in the order of microseconds. So if your workloads are very sensitive to latencies, you want you have highly transactional workloads, you need microsecond latencies, then UltraM is a very good fit. It gives you high IOPS as well, but not as much as NVMe.
Hardware RAM disk.
Hardware RAM disk, yes.
So let me spend a little more time going through the details of stretch clusters. I think use case is very clear. A lot of customers using a stretch cluster for planned maintenance, disaster avoidance, and automated recovery. More details here. I talked about the latency and network configuration between the main sites and the witness. Just a couple of other things is, if you're running a stretch cluster, ideally you want to run your servers as 50% of the capacity. We tested actually, the nodes in the cluster could potentially run at the capacity very similar to a standard vSAN cluster, but ideally you should run them at 50% capacity, because if you have site failures, you want to make sure that if a site fails and HA restart all your VMs on the other side, you're going to have the similar quality of service. Spend a little more time on the networking here. For the networking between the two main sites, as I mentioned, it should be less than 5 millisecond latency, and we support 10, 20, and 40 gigabit per second. We require multicast. This could be L2 configuration or L3 configuration as well. One thing I want to mention here is, if you have lower, we talk to a lot of customers who cannot dedicate a 10 gigabit per second for vSAN. If you have a smaller configuration, for example, if you have 5 plus 5 plus 1, then you can actually utilize 4 gigabit per second for vSAN traffic, and then that's going to be good enough, basically. The other aspects I want to mention in the next slide is, let's spend a little more time on the witness VM. Witness VM, it doesn't have any data, it only holds metadata, it's not running any VMs, and if the witness VM fails for whatever reason, let's say you're running it remotely on the third site and its disaster happens or the site crashes, what you can do is you can easily deploy a new witness VM, connect to the cluster. In that case, we transfer the object metadata to the witness, and then you can continue running without any interruption. In terms of resource requirements, it depends on the scale that you're running. For example, if you go to 15 node plus 15 node plus 1, you need to have 32 gig memory, 2 vCPU, and for storage, as I mentioned, you need to have 16 megabytes for each object you have in your cluster. So you can do the math, but in the maximum scale, if you deploy to 15 node and thousands of VMs, then we require 300 gigabit disk for capacity and 10 gig for caching tier. The one thing I want to mention here is that for caching and capacity on the witness, you can use magnetic disks. You don't need to have any SSDs on the witness side. Basically what we do when we deploy the OVF, we just mark the disk, and then you don't need to do anything else. It just could be all positioned on the magnetic disk. If you go on the lower kind of deployment, maybe you go with medium with 4.4 plus 1, we can deploy memory 8 gig, CPU 2 vCPU, and for storage you need 50 gigabit for capacity and 5 gigabyte for caching. And as I mentioned, you can use tin provisioning for the disk, so you can save on capacity in case you're deploying multiple clusters. The other concept we introduced here is preferred fault domain. The main reason we are introducing preferred fault domain is the fact that the only time it's going to be used is when you have network partitioning between the two main sites. So imagine you have site 1 and site 2, and you end up, the network goes away between the two main sites. In that case, both of the fault domains can actually establish a quorum with the witness. If that happens, then basically the preferred site is going to be preferred, and the VMs on the non-preferred one, HA is going to restart them on the preferred side, basically. Make sense? So preferred side is going to be only used, so there is, in terms of like store resources and everything else, the two sites are exactly the same. The preferred is going to be only used when you have network partitioning between the two sites, and that's going to be used to decide which one is going to survive and which one is going to fail. If you decide to change a preferred site, it's a setting you can easily change it through our UI as well. Let me spend a little more time on the read operation. So if you look at vSAN architecture today, I think Rakesh mentioned that we don't, in a traditional vSAN architecture, we don't have any read locality at all. The main reason, and for example, if you have 10 node cluster, your VM could be running on node 1 and your data could be on node 5 and node 10 basically, right? The main reason there is that when you're running local data center 10 gig, your network latency is so small because it's basically in microseconds, right? And your SSD latency is like milliseconds, so potentially it's like 1 or 2 milliseconds. So you can potentially ignore the network latency in terms of performance, and that's the main reason inside the central data center we don't have real locality. But as we look to stretch clusters and we look into future with like some of the NVMe devices that's coming, at that time network latency matters, and that's the reason we are implementing read locality here. The way it's going to work is if you have, imagine you have VMs running on fault domain 1. If the VM does a read operation, we prefer the local side first before we go to the second side, which basically means there is no read operation in most of the time going across the network to the second side. The only time you might see read going to the other side is the time that you have node failures and the data doesn't exist in site 1, and in that case we might go fetch the data from site 2. Write operation, because a switch cluster is active, so we replicate the writes to both sides. So when a VM does a write operation, the write goes to fault domain 1 and then goes to the fault domain 2, and then it gets acknowledged, and then at that time we are acknowledging the write to the VM. The key thing here you should notice is at any given time if any site fails, the other one can take over without any data loss. Also, as you think about this, that's one of the key reasons we require 5 millisecond latency between the two main sites, because if you have more than that, the latency for the write is going to be very high. Couple of things I want to mention, interaction between these stretch clusters and availability product. If you have two sites, let's say you have LA, in that case, sorry, if you have New Jersey, New York, and this is your third site in LA, what you can do is, a stretch cluster is going to give you regional protection. So for example, if site A goes down, then site B can take over. We wanted to provide geo availability as well. So you can use vSphere application to replicate those VMs to a third site. So if the whole region goes down, then you can actually restart those VMs on a third site as well. So this could be, for example, your London site. And for vSphere application, as I mentioned, we have 5 minute RPO now. If you want to expand on it, you can, if you have a lot of VMs, you can potentially use Site Recovery Manager on this site as well. So you can have orchestration and tests of disaster recovery as well. Let me spend a quick overview of the remote office branch office as well, provide more details. I talked about the witness for remote office branch offices. The requirements we have for the witness is you need to have 8 gig memory, 2 vCPU, and for storage, it's actually much less than that, but ideally you want to have 15 gig for capacity and 10 gig for just the caching, but as I mentioned, those could be all magnetic disks as well. Rakesh?
Yeah. So before I get into some of the details, based on the three-pronged strategy that I just mentioned earlier, wherein vRealize Operations Management Pack provides global cluster visibility, Health UI provides per cluster, and we also want to provide APIs to integrate with third-party tools. So how many in the audience here would prefer using vRealize Operations to manage your entire vSAN cluster? Okay. Around 30%. Okay, and the rest of you are happy with Health UI? How many would do Health UI? Just have Health UI and nothing else. Wow, 0, 1. Okay. And APIs. How many of you are interested in having APIs to integrate with your environment? Okay. Right. Good. Thanks. So. Just getting into some details of what the vRealize Operations Management Pack provides. I know Neil just provided an overview of how he is using it, but some details, we provide exploratory dashboards and heat maps. So essentially, it comes out of the box. The dashboards that come out of the product are out of the box configured for vSAN. So you look at key vSAN metrics like performance, capacity, and availability, and they map into health, risk, and efficiency scores. It also gives you heat maps of various virtual and physical components. So for the physical components, it would be like how your controllers are performing, what are the latencies of your SSD, and what are the latencies of your HDD, what is your SSD eviction rate, because the destaging times can actually impact the performance for vSAN, and those are some of the examples. From a proactive alerts, notification and remediation standpoint, it looks at both virtual and physical components. So if you have a network congestion, it will actually come back and tell you, either you have too much congestion on the network, or it would say something like, you have a 1 gig link, you might want to upgrade to a 10 gig link, depending on the amount of cloning operations that you're running in your network. From a hardware standpoint, it will give you a proactive failure notification for any HDD or SSD that has failed or that is likely to fail. And we are able to predict failures based on the smart data. As far as performance is concerned, it will tell you which specific hosts are becoming hot, where are you seeing very high latencies. Maybe there are specific workloads that are running on certain hosts that is causing the latencies to go very high, and it gives you an idea of when you actually need to do a rebalance in the cluster. And finally, capacity planning. As I mentioned, there is a capacity planner. You can input information as it relates to historical data, and then it'll come back and tell you how much more hardware you need to buy, how much more HDD, SSD, and compute nodes you need, say, over the next 6 months, 12 months, or 3 years. It's all configurable, so there's a detailed capacity planner built in. From the health UI, I went through most of the features here. One thing I did want to mention is we are introducing support for stretch clusters as well now, because that's a new feature. So we will be providing a lot of metrics on stretch clusters. We are also working on providing, the latest release actually supports SNMP v3. So you can use SNMP traps and integrate it with any tool, any management tool in your environment as well. And you can also do custom scripting and emails via vCenter alarms. Finally, the vSAN assessment tool. Just one specific thing I wanted to mention here was from a sizing standpoint, it will actually come back and tell you whether 80% of your environment is fit for hybrid and 20% is fit for all-flash, and then it will actually configure a hybrid and all-flash cluster for you. Right? And then if you're not satisfied with the configuration that the tool provides, you can always go and change components and figure out, if I swap this drive, this SSD with something of my choice, then how much is it going to change from a cost perspective over time. With that, I'd like to hand this over to Neil, who's going to talk to us in more depth about his deployment.
Yeah, thank you. So it was basically a year to the day that I was here presenting on what I had just deployed with regards to vSAN, and that was at the time, 0 virtual machines running on it. We'd just gone through all the burn-in tests, and we had a relatively good idea of how it looked. Now, after a year of running it, we have many more metrics of this is how it performs. These are the things that we need to consider. So as we move forward and purchase more and more and more capacity, we now know exactly what we should buy and where we should focus our attentions on. So just a little bit about Indonesian Cloud. So public cloud service provider, more accurately managed service provider, locally owned. Even though the name says Indonesian, it is actually not government owned, so private owned. 150 customers, direct customers. We focus a lot on indirect customers, so resellers. And I have absolutely no idea how many end customers we have, none at all. vCloud Air Network is actually pretty important. We needed a way to be clear in the market that says, this is our platform, this is what it's based on, it is reliable, it is stable, it is enterprise class. And the vCloud Air Network powered badge gives us a stamp of approval. So it's actually a really important sign, not so much that you're just a member of a network, but your platform complies to VMware best practices. So back in 2011, we had no customers, we had no brand, we had a market that didn't have a clue about cloud at all. But we had investors with a very good idea and very deep pockets. So move forward 5 years, and we've now grown to just over 1,500 virtual machines. Still small, I know it's still small. 150 plus enterprise customers, all mission critical. You know, I make no excuses to say that we are the most expensive provider in the country because you get what you pay for. Our goal is to be the most trusted, most reliable, most secure provider, and that's from the best hardware, best data center, and best people. So three data centers, just in the process of adding a fourth. vSAN across all 3 of these data centers. Not yet stretch clusters, but I'm, like you guys, equally excited by that possibility. Two of the data centers are actually quite close together, so we have dark fiber between them. All active, all separate internet POPs, fully redundant, state of the art. Now what's interesting is when you speak to people about we have a VMware powered public cloud, everybody always responds back, but because you run that, you're not as dynamic, you're not as feature rich as Amazon or Azure or the others. And that's not actually true. You know, we are feature equivalent. We have the ability to do auto scaling, we have the ability to do load balancing, we have the ability to do firewalling. Now every single feature, like for like, you can go match against Amazon, Azure and others across a VMware powered cloud, and almost everything is there. Almost everything. Now, virtual SAN stuff, let's get some fun here. So, three clusters in total, one cluster per data center. Each cluster, 12 nodes. Supermicro, it doesn't really matter, but Supermicro Fat Twin. 240 cores, 3 terabytes of RAM, 225 terabytes of disk, roughly. 12 SSDs, 60 hard drives, probably not enough, if I'm honest. 190,000 IOs and 2.2 gig of throughput. Yeah, pretty cool numbers. That's per cluster. You see there 5 milliseconds average latency. Yeah, that average, that's actually pretty reasonable. It can pass all of the jet stress performance requirements. So our 60 drives, we went with 4 terabyte Nearline SAS drives. Mainly because I make money selling capacity, so I want as much capacity as I can in as small a space as possible. And one of the interesting things there is Nearline SAS drives, they've got some smart queuing in them, but they are still relatively slow from an I/O and throughput perspective. So we're only seeing 80 IOPS and 5 megasecond from each drive. And the SSD is about 36,000 IOPS and 235 megasecond. Now this is important here. Now FTT, that's more than just failures to tolerate. Okay, it actually has another effect, which is it is your write penalty from performance. Okay, so with FTT set to 1, however many drives or SSDs you have, divide them in half, and that is the number of drives that are able to service I/O requests for writes. Okay, reads, you get everything. Writes, you get half. Just think of it like RAID 1. So our peak read performance, very, very high. 432,000 IOs. Peak write, 216. Now, what's interesting here is the sustained write. So if you've got a platform that's bursty, so you've got peaks and troughs, okay, cool, fine. If you have an environment that is sustained, high speed, throwing data at the vSAN cluster, you need to consider your sustained write performance. And this is where I probably made a little bit of a mistake there, because our sustained write is actually only 2,400 IOPS and 150 megasecond. So if I'm ingesting at 500 megasecond and destaging at 150, we have an issue. Usually the cache overflow. So the vRealize, this is a sample from our dashboard there. So you can see up the top you've got a view of the drives. So you can see the green drives, that's the latency for each drive. The orange, so here you can see the cluster is slightly unbalanced. And this is because we've got a combination of VMs with a stripe width of 1 and a stripe width of 5. So we've got a little bit of unbalanced I/O load there. You can see average latency 5 milliseconds, 1,054 virtual machines on that particular vSAN cluster, which is quite cool when you think about what it is. Yeah, it's not even half a rack. And you can see all of the command latencies for every single host. These are the type of metrics that you need to be able to say, yes, it is performing as expected. And in my case, yes, I can keep selling more and making more money without having to buy more hardware. So the vSAN benefits, the transparent thin provisioning. Yeah, we've got 141% over allocation of storage. Now, with regards to real storage consumed, there's actually only about 65 terabytes per cluster here. Yeah, the transparent auto tearing, so being able to keep all hot I/O in SSD and all cool or colder I/O in spinning disk. That obviously saves a heap of money as opposed to buying all flash or lots and lots and lots of 15K drives. Zero touch array. The ability to fine-tune your environment, so we can create larger SSDs. We can now say we want 1.2 terabyte SSDs, or we can have smaller SSDs, different types of hard drives. All that granularity really gives you a fine-grained control. Now, our policy for scaling is to not scale a cluster. We like to say 12 nodes is a cluster. We buy 12 nodes. When we outgrow 12 nodes, we buy 12 more, and 12 more, and 12 more, and 12 more. To be frank, it's quite scary to think about plugging in another server and letting everything expand. But by having a block, you know this block can do this I/O profile. It can support this many virtual machines of this type of workload. It's very easy to predict, to model, to sell. We're having to move to a new vSAN ready framework. Our existing environment was all vSAN ready nodes. It doesn't map through to the new vSAN ready. We'll be adding more hard drives, which is actually going to be good anyway because our D-stage performance is not as we'd expected. So moving to the new vSAN ready node.
Fantastic. Thank you, Neil. So let's just open it. We have less than 5 minutes, so let's open it up for questions.
Please
yes.
Go ahead.
Can we get the mic, please?
So I have two questions.
Yeah.
One is about the ready node.
Yes.
How is it different with the Evo Rail?
Okay.
The other one is in the stretch cluster, you mentioned that the I/O will get acknowledged once it's committed on the other side in the scan. So does this mean that only one copy of virtual machine will be there in the secondary data center, not in their own data center?
Okay.
Because in the presentation it looked like this only.
Okay. So let me answer the ready node question. So it's very simple. Evo Rail is a fixed appliance, so you don't have flexibility in changing capacity, anything actually. Ready nodes are more flexible. So we provide you a guidance. You can actually, when you enter this queue, it comes up with a BOM, but you have the ability to add more capacity, add more memory, add more CPU. There's some guidelines that you need to stick with in terms of specs, but that's all programmed into the OEM ordering system. So you get more flexibility with ready nodes, but then you're using a combination of certified components, so you get more predictability and scalability as opposed to building your own components. And with Evo Rail, it gives you a fixed appliance kind of an experience, and you also have the Evo Manager and things like that. So it's a different UI, different management. It gives you more of an appliance experience.
And for a stretch cluster question, your VM is running at any given time in one site, right? So your VM is running, when it does the write operation, the writes are going to go to both sides, gets acknowledged, and then we acknowledge the write to the application, basically. So at any given time, your VM is running in one site. Yes, if a site goes down, HA would restore the VM on the other side. If a node goes down, then DRS rules is going to specify basically how that VM is going to get restored. HA is going to restore that VM. It could get restored on the local side. It could get restored on the other side.
Get it started on the local side, you should have a copy on the local side as well, the other copy. So it will be there.
So the question is, when you restart the VM, does the copy need to be on the local side? The answer is no. When we implement the read locality, if the copy doesn't exist on the local side, we can go across the network and get the data. Okay. So if the VM gets restarted on the local side, we're going to go across the network, do the read operation, and send it back to the application.
Okay. Thanks.
Right. Any other questions?
There is some deduplication functionality on the storage.
I'm sorry, can you say?
Do you have deduplication on the storage level?
So the question is, do we have deduplication on the storage layer or not? I think, as you know, we announced in our beta program for the upcoming release, and in upcoming release, we are adding deduplication to our features. It doesn't exist today, but it's coming.
You can try and sign up for that. The beta program goes live in November.
Actually, I think I have the slide here, if I'm not mistaken. Yeah.
And this will give you, the beta has deduplication, compression, and erasure coding. So a lot of storage efficiency features. You can sign up for the beta. It's in November.
Is there any possibility to provide storage to external systems via NFS or whatever?
No, at this moment, no. You can't actually use vSAN storage for external outside, but we get that a lot for physical servers and stuff. It's something we are looking at.
So there's actually a company called Soft NAS, so SOFT-NAS. They have support for vSAN.
Yeah, actually, that's a great point. We are to our partners. I think Nexenta also has a solution with vSAN as well. You can use file server on that. But you're right that I think a lot of our customers are asking for potentially iSCSI support or NFS and CIF support on vSAN, and we hear that.
It's not native today. We have some partners, but we are considering providing native support in the near future.
Any other questions, comments?
Is it possible to use that witness VM with a non-stretched cluster?
Actually, you could. So here's the thing, right? You could have a situation in the remote office branch offices. I've talked to some customers. They have 2 rooms. Yeah, they have 2 racks. You can put it there, and then you can put the witness in a 3rd room potentially. Yeah, absolutely, you can do it. And it's going to be all local to that remote site. If you do it that way, it's all within one building, then there is no advanced licensing. It's going to be all local licensing. And for our remote office branch office, I think I mentioned we had introduced per VM licensing. So if you have like 5 to 10 VM in the remote side, it might be better for you to go per VM licensing anyway.
Depends. You'll have to do the math to figure out.
We're more than happy to work with you and come up with the optimized way of the cost. Any other questions or comments? You have a question? Oh, okay. We're going to be around here, so please come up front if you have any questions or comments. More than happy to chat about the different things.
Right.
Thank you so much.
Ladies and gentlemen.